Okay, now let's continue with data preparation and specifically the Tidyverse package. So Tidyverse is a package that basically provides you functions whose functionality correspond kind of directly to the names of the functions. So the idea is to have functions where the name of the function already tells you what the function is doing. And this is super useful, especially if other people are trying to read your code, or if you're unsure what the name of the function is you're looking for. Well, your first guess is always should be as close as possible. So if you want to filter data, the function is called filter. If you want to select certain variables, the function is called select. If you want to summarize, function is called summarize. You can mutate variables, or you can arrange data. And basically they're all built on pre-existing functions. So there's everything you do with these functions you can do with like brackets, logical expressions, and so on. But it's just much more readable that way, and usually it's much more much easier understandable, and the functions are very easily usable. So important to note that the first argument for each of these functions is the data object, which means that we can always just use pipe and leave the first argument out and directly supply the functions according to which we want like the other options of the functions, how we want it to operate. So to give you one example, in the last lesson we learned about filtering using logical expressions. So remember, we filtered, for example, wages for people who have more than 10 years of schooling and more than 10 years of experience. And we did this by using the AND operator and two logical expressions. So it would also only return us observations of people that fulfill both of these requirements. However, if we use the filter function from the Tidyverse, this is much more readable, because now we just supply wages using the pipe symbol, and then we just list the conditions. We list schooling larger than 10 and experience larger than 10. And the returning value is exactly the same. It does exactly the same. It is just much easier to apply, to understand, and also to understand for people who look at your code as outsiders. Again, notice that here we use the pipe symbol to input the data, and this works because the first input that this function requires is the data set. So R knows that it should use the data that comes from that is supplied by the pipe as the first argument, and then interpret the arguments that we supply as the filtering conditions. So selecting data previously, or selecting different variables, was done by, for example, opening the square brackets. And here is we have a vector, opening the square brackets and then supplying the names of the variables as the second argument, where we left the first argument empty, which meant that we just want to have all the row observations. And this vector that contained the variable names selected only these three variables. Now, the Tidyverse provides us with a function called select, and this is of course very straightforward. You just tell select which variables you want, and the pipe symbol supplies select with the data from which it selects these three variables. If you want to drop a column, this is also very straightforward, because you just apply select on a negative variable name, so to speak. So you type minus, and then the variable that you want to drop. And what this will do is basically it will select all variables except experience. Very similar, if you still want to use square brackets, what you could do is you could simply type negative the column that you don't want as a second argument in the square bracket, and it will also display all columns except the fourth one. If you want to drop more than one, you could just use a vector here and supply minus and then the vector of columns that you would want to drop. So what doesn't work is negative and then the name of the column. However, what you could do instead is you can supply the name of the column that you want to drop and assign it the value null. And null basically tells R that this column should just be dropped. Mutate is a function that is very similar to what we did when we used the $sign and referred to different columns and basically either change their values or change the data type, or we refer to a column that didn't exist yet and assigned it a value, and then R would automatically append an additional column to our data set. So what you do with mutate is essentially the same. You pipe your data into mutate, and then you refer, for example, to a column that doesn't exist yet, and tell it should be the squared value of experience, which is an existing variable, and it will just append this as an extra column. On the other hand, if you would type experience here and then equals experience squared, it would just replace experience with the squared value of itself. Very often, something you want to do is you want to have a summary table that contains, for example, mean, the standard deviation, min, max, or quantile, something like that. And what you can use from the Tidyverse is the summarize function. And basically what this does, it uses the data that you supply to it, and then it creates a new table that contains all the variables, all the summary variables that you created inside that function. How this looks like is, for example, you want to have the average wage, just the average wage in the table. So you pipe the wages into summarize, and then you define a new variable called average wage, and you just say you want to have the mean wage from the wages data set. So wage, notice that wage is a variable in the wages data set. So it's only one column. And the result, of course, will be a table with exactly one observation. There is every statistic that you would want to have available: the mean, the median, the standard deviation, variance, quantile. There's a position like the first, last, the nth observation. You can count how many there are. You can count how many distinct there are. And if you have been working with Stata before, this should remind you of the collapse function, where you essentially also take a large data set and you just collapse it to a number of summary statistics that you individually call for each variable. So let's say you have 50 observations, but you want to have the summary statistics of several variables. You want to have average wage, you want to have the standard deviation of the wage, average experience, and the standard deviation of the experience. You would just, again, pipe wages into the summarize function and then define these variables separately using the mean or the standard deviation function. And the resulting table, or it will be a tibble, contains 4 observations for all of these 4 summary statistics that you created in that function. So another very useful function is group by. Again, this is something that should be very familiar to you if you have been working with data before. And basically what group by does is it supplies the data grouped by a certain variable or several variables, in fact. So for example, if you want to summarize the wages, the mean wage and the standard deviation, but you want to have this done separately by sex, you would just have an intermediate step. So you pipe wages into the group by function, you group by sex, and then the resulting data set you pipe into the summarize function. And what this does is it basically just applies summarize separately, once for all the observations that are male and once for all the observations that are female. And it will just, as a result, give you 2 rows because it executed this summary statistics twice. Arrange basically just allows you to sort data increasingly. So what you do is you would just, for example, pipe data into a range, and then you tell according to which variable you want to sort. And so in this case, we sort by experience, in ascending order. And so we have here 5, 8, and 10. Yes, that's all this function does. Also, if you want to sample data, which is going to be quite relevant especially when we talk about machine learning and resampling methods later in the course, oftentimes you would like to draw subsamples from the data that you have. And what you can do is you can use either sample n, which just draws a sample of n observations from the data. It has an options for replace, meaning sampling with replacement or without. Or you can sample a fraction of the data. It just tells you like sample 50% of the data. And again, you can replace or you can replace with or without replacement. Okay, so now I would like to go to an example. So the slides contain an example for fuel economy, but let me show you a live example in our studio where we combine a bunch of these commands together. So here I have the Tidyverse and Rio that we had before, and I called another additional library called ISLR, which is a library that comes from a textbook. It just contains a bunch of data sets. And one of the data sets that it one of the data sets that it contains is a data set about colleges and the tuition of these colleges. So the data set is called college. So let's take a look. So it basically contains out-of-state tuition, whether the college is private, applications, etc. So what we would like to know is maybe if colleges, whether private colleges have a different out-of-state tuition than public colleges. So what we could do is we could say use college, and let's say we want to filter only colleges that have a certain graduation rate. So we only want to have colleges that, let's say, have above 75% graduation rate. So we filter graduation rate larger than 75. Then after we filtered, we group by private, because we want to have the mean out-of-state tuition separately for private and public colleges. And then we summarize and we create, let's say, call it tuition mean state. If you run this, you now get a table with two data points. One is for public colleges that have a tuition of 8,600, and private colleges have a tuition of 13,900. Yeah, and here's just another example, a little bit more, a little bit larger example where you have a few more intermediate steps, which is probably a good example that might be useful to take as an example for when you're solving the assignment. So a more general function than summarize is the summary function. And basically, if you apply the summary function on a data set, it will just by variable give you the most common summary statistics that you might want to see, like the minimum, quantiles, median, mean, and the maximum, which is just very useful if you just want to get an overview or just have these very common summary statistics easily provided.